Okay, so today we're going to talk about theorems about differentiable functions. What happened? Monday is project check-in day, and your project due dates are coming up the week of Thanksgiving. Sorry, that's a Friday and a Monday, not the week of Thanksgiving. It's Friday and Monday. So Monday's project check-in day, and I'm also going to give you your third take-home quiz. That'll be due the next class. And the next class, you have an in-class related rates quiz that you will be like a group endeavor. And you already have it. You can look at it ahead of time. You have the answer. So all you have to do is figure out how to get there. All right. Any questions about what's coming up? Yes. I have not graded the second two projects yet. No, I'll get it to you before test 3. Okay, so in this class, we're going to discuss 3 theorems about differentiable functions. The mean value theorem, which is new. The increasing function theorem, which we have known for a long time. And the racetrack principle, which is new. So some of today will be a bit more theoretical than usual. So you're going to be strengthening some new math muscles. Yeah. All right, so the mean value theorem says if f is a function that is differentiable on a, b, that means you can take its derivative from the x value a until the x value b. There's no corner points, there's no holes, there's no discontinuities. It's just nice and smooth and continuous. All right, so if f is a function that's differential on a, b, there's at least one number c between a and b. There's one number between a and b, so that f prime of c is equal to f of b minus f of a over b minus a. Okay, so f prime of c. The derivative represents the slope of the tangent line. All right, so this is the slope of a tangent line at some point c in between a and b. F of b minus f of a, what over b minus a, what does that represent? Yeah. Okay, so, yep. Yeah, so graphically, if I subtract the y values of the function and divide by subtracting the x values of the function, you get the slope of the line connecting those 2 points. So this thing is the slope of a tangent. Yeah, f prime of c is the slope of a tangent. And this thing is the slope of a secant. Right? So if I draw the secant line in, the points connecting a comma f of a to b comma f of b, it's got some slope. The mean value theorem says that if f is differentiable, then it guarantees that somewhere between a and b, you can find a c value so that the derivative there, that is the slope of the tangent line there, is parallel. That is a terrible picture. Sorry. Is parallel to the secant line. Draw that a little bit better. Maybe it's like here. It's the board, yeah. That's a little bit better. So does that make sense? So in English, the mean value theorem says that there is some tangent line that's parallel to the secant line. All right, I've got a quick little demo. Okay, so here's my little demo. I can show the secant line. So there's my line connecting A to B. And then I can slide x along, and I can see the tangent line, and I go, there's my c, right? There's the place where the tangent line is parallel to that secant line. The mean value theorem guarantees that there's at least one place that happens, but it could happen in more than one place, right? If I keep going, there's another one over here. The equation of what? It's not a sine wave, it's a cubic polynomial. Yeah. So we can slide x, do it on its own. All right, and then we can have it find the c value for us. I'll reset and find c. There it is. It says c happens at 1.225, and then there's another one at 2.775 hidden. All right. Okay, so next thing. Another theorem. Suppose two zombies, Goeth and Hertz, start a race in the same location. If during the race, Goeth was consistently shambling slower than Hertz, what can you conclude? Hertz is going to win, yeah. They start at the same place. One's going slower, then that one's going to lose, right? Hertz wins. Yeah, they're zombies, so they shamble. Okay, let's say two zombies, Goeth and Hertz. They complete a race in a photo finish. They tie. They cross the finish line at the exact same time. If during the race, Goeth was consistently shambling slower than Hertz, what can you conclude? Yeah. Goeth had a head start, right? Hertz started later. Means the whole time. The whole time he was going slower. Yeah. So Hertz must have started later. Isn't that the same thing? Giving Hertz a head start. Oh yes, he's okay. You're right. Yeah, you're right. Goeth had a head start, so Goeth, not like Goeth got to start first, but he started ahead, right? Goeth started closer to the finish line. Okay. Okay, so this leads us to the racetrack principle. So it says, suppose you have two functions, g and h, Goeth and Hertz, right? And they're both differentiable on a to b, and g prime is always less than or equal to h prime. That's saying Goeth is always slower than Hertz, right? That's the speed, g prime and h prime. Okay, so if g of a equals h of a, that means they start in the same place, right? Then how did g and h compare at the finish? Yeah, g is less than h, and g is always less than h, right? If they start in the same place, and the whole time Goeth is slower than Hertz, then the whole time Goeth is going to be behind Hertz. And I put an or equal to because they started the same, but then after that, Goeth is always behind Hertz. Okay, so if they finished at the exact same time, right? Goeth and Hertz, they have a photo finish, then what do you know? We said Goeth had to have started closer to the finish line, right? So Goeth has to always be ahead of Hertz or equal to Hertz. And Hertz is like catching up the whole time, right? Goeth started closer to the finish line, and he's running slower, so Hertz is catching up, and then they finish at the exact same moment. So Goeth gets a head start, and he's always ahead until the very last second when they cross at the same time. This is related to the video. How? Yeah. How is it related? Did anybody watch it? The video of Ian racing. Yeah, it's fine. Well, I had to solve the Rubik's Cube first. So the video that I asked you to watch was okay, so that's the racetrack principle. That's it. You can start your activities. So the mean value theorem says that if you connect the endpoints of the interval with a secant line, that's at 4, right? The slope of that line, calculate the slope of that line, you're guaranteed to find a tangent line that has the same slope, somewhere between 0 and 4. So first I'm going to calculate the slope of that secant line. Right, so this point right here is 4, 2, because that's a graph of square root x, right? And this is 0, 0. So your slope's going to be 1/2, change in y over change in x. And then your derivative, y prime, is 1 over 2x squared. So the mean value theorem guarantees the existence of some c so that the derivative is equal to 1/2. Yeah, what am I doing? Yeah. Yeah. So this is your derivative. The mean value theorem guarantees there is some value in there where the slope of your tangent line or your derivative is equal to the slope of your secant line. And then you just solve this thing for x. So this would be at there's your special point. 1, it's between 0 and 4. And if I draw a tangent line at 1, I get a parallel line to the secant line.